Welcome back, everyone. In today's tutorial, we'll be building an exciting weather prediction web app using machine learning and the Python framework Django. This app will provide real-time weather data for any city you enter, and based on these live conditions, it will predict a detailed forecast for the next few hours, including both temperature and humidity. We also have a chart here to make the data visually appealing. Before we dive in, let's recap the previous tutorial. If you followed along, you'll remember that I worked in Google Colab, where I used the OpenWeatherMap API to fetch live weather data. I also gathered historical weather data and trained a machine learning model to predict if it's going to rain and forecast the weather for the next 5 hours. Once the model was trained, I used live data to make predictions. If you haven't seen that video yet, I highly recommend watching it first because it lays the groundwork for today's tutorial. The link to that video is right above, so be sure to check it out before proceeding. Alright, now that you've seen how the code works in Google Colab and have a clear idea of what we'll be building, it's time to get started on creating our weather prediction web app. For this, you'll need two things installed on your system: Visual Studio Code and Python. If you don't have them installed yet, no worries. Just search for VS Code and Python on Google, and you'll find the official websites where you can download them. Install Python first, then VS Code. Make sure you're downloading the latest versions. Let me also show you. To install Python, search here Python Download. You'll see a link to Python's official website. Click on it, and here you can download and install Python. And for Visual Studio Code, search here versus Code Download. Click on the link to the official VS Code website. Download the latest version for your operating system. Once it's downloaded, install it, and you're ready to go. Instead of VS Code, you can also download PyCharm, which is easy to use. However, I'll be working in VS Code. Now open VS Code. This will be our main workspace for building the web app. If you're new to VS Code, don't worry. I'll guide you through every step. Now, let's start by opening the folder where you want to create your project. Click on File at the top, then Open Folder, and select or create a new folder for your project. After you've opened the folder, you'll see that the workspace is ready and we can start coding. Next, we'll set up a virtual environment for our project. This is important because it keeps all the necessary packages and dependencies organized within your project. Let's create that environment now. To do this, open the terminal in VS Code by clicking on Terminal in the top menu and then New Terminal. This will open a terminal window at the bottom of the screen. Now, in the terminal, type python-menv myenv. This command will create a new folder named myenv in your project directory, which will contain the virtual environment. Once the environment is created, we need to activate it. If you're on Windows, type this. And if you're on Mac OS or Linux, use source-env/bin/activate. You'll notice that your terminal now shows myenv at the beginning of the line, indicating that the virtual environment is active. Now, with our virtual environment activated, let's install Django, as this is the Python framework, which we will use for this project. So type pip install Django. Once it's done, we can start creating our Django project. To create a new Django project, type this. This command will create a new folder named Weather Predictor in your project directory, containing all the files we need to start our web app. Inside this folder, you'll see a file named manage.py. This is the main file we'll use to run our Django server and manage our app. Before we move on, let's make sure everything is set up correctly. Let's navigate into the Weather Predictor folder by typing cd Weather Predictor. So type python manage.py run server to start the development server. If everything is set up correctly, you should see a message saying that the server is running, along with a link. Open this link in your web browser and you'll see the default Django welcome page. This means our Django project is set up and running successfully. Now that our Django project is up and running, it's time to create a new app within our project. In Django, an app is a module that provides specific functionality for the web application, such as managing weather predictions in our case. To create a new app, go back to the terminal. Make sure you're still inside the Weather Predictor directory and type python manage.py startup forecast. This will create a new folder named Forecast inside the Weather Predictor project directory. The Forecast app is where we'll write all the code for our weather prediction functionality. Next, we need to tell Django that we've created this new app. To do this, open the settings.py file in VS Code. Scroll down to the Installed Apps section. This is a list of all the apps that are active in your project. To activate our Forecast app, add it to this list like this. Save the file, and now Django knows about our new app. Before we start adding weather functionality to our app, let's create a simple view to make sure everything is working. In the Forecast folder, open the views.py file. This file is where we define the logic for our web pages, including how data is processed and presented to the user. To begin, we'll create a simple view that returns a basic HTML page. So in this write, this line imports the HTTP response class. This class is essential because it enables us to create HTTP responses that the browser can understand. When a user visits our web page, we need to return a response, and HTTP response helps us do that. Next, define a new function called WeatherView. This function will handle requests to our app. The request parameter represents the HTTP request sent by the user, containing information like form data, query parameters, and more. Next, type This line returns a simple HTML response. Here, we're sending back an HTML heading with the text Weather Prediction App. When the user accesses this view, their browser will display this heading as part of the web page. Next, we need to connect this view to a URL so that when someone visits our site, they see this page. In Django, we use URL routing to map URLs to specific views in our application. This allows users to access different parts of our app through distinct URLs. In the Forecast folder, we need to create a new file called urls.py. This file will contain the URL patterns for our app. URL patterns are essentially a list of paths that Django checks when a user makes a request. Now, let's add the code to the urls.py file. This line imports the path function from Django's URL module. This path function is then used to define a URL pattern. Then write from .import views. This line of code imports the views from the current directory, indicated by the dot. This allows us to reference the weather view we defined earlier. Next type, URL patterns. The URL patterns list is where we specify the URL patterns for our app. Each entry in this list defines a specific URL and what view should be executed when that URL is accessed. Now type path views.weatherView. Name equal weatherView. The first argument means that this pattern matches the root URL of our app. In other words, when users visit the base URL, they will see the response from the weatherView function. The second argument views. weatherView tells Django to call the weatherView function we created when this URL is accessed. The name equals weatherView gives this URL pattern a name, which can be useful for referencing it elsewhere in our code, such as when creating links or redirects. By setting up this URL routing, we ensure that our web application can respond appropriately when users visit our site. Finally, we need to include this forecast app's URLs in our main project's URLs. Open the urls.py file of the project directory and update it like this. First, we need to import the include function from django.urls. This function allows us to reference other URL configurations, such as those defined in our forecast app. Next type, path. Include forecast.urls. This line is where we include the URLs from our forecast app. The first argument means that this pattern matches the root URL of our project. Essentially, it indicates that when users visit the base URL of the project, Django should look for URL patterns in the forecast.urls module. Then, this part tells Django to include all the URL patterns defined in the urls.py file of the forecast app. This means any URLs we defined in that file, like the weatherView, will now be accessible through the main project's URL. By including the URLs from our forecast app in the main project's URL configuration, we create a seamless connection that enables users to access the weather prediction functionalities we are building. Now, let's test everything. Save all the files and go back to your terminal. First, activate the virtual environment. Then, navigate to the project directory and start the server by typing Once the server is running again, open your web browser by clicking on this link. You should see the text Weather Prediction app on the page. This means our app is set up correctly and is ready for us to start building the weather prediction functionality. Great! Now that we've set up our forecast app and confirmed that it's working, it's time to start building the core functionality, fetching live weather data from the API and making predictions using our machine learning model. For this next step, in the views.py file, we'll use the same functions that we defined in Google Colab, along with the libraries we imported there. This will enable us to implement the weather prediction functionality in our Django web app. First, copy all the libraries and paste these here. Next, copy and paste all the functions as it is. Now all functions are the same, but there will be some changes in this main function, particularly for handling user input and managing historical data. Delete this HTML tag. In Google Colab, we used the input function to get the city name. But in Django, we handle this differently. Here we check if the request method is post, meaning the user has submitted data through a form. For example, when a user enters a city name and clicks Submit, the data is sent to the backend. We need to write an if condition to check for this request method and process the data accordingly. Then, we extract the city value from the form using this. This replaces the input function we used in Colab. Now copy the code from Google Colab before this print statement. In Colab, we used the print function to output data for debugging. However, in a Django app, we don't need a print function because our data will be rendered on a web page, not printed to a console. Therefore, remove any print statements from the code. Here, we also need different syntax to get historical data. In Colab, we likely used a local CSV file to load historical weather data. We need to do the same in Django by ensuring the CSV file is accessible within the project folder. Place the CSV file inside your Django app folder. You can find the link to the historical data in the description of part 1 of this tutorial. Now, write CSV or path equals os.path.join and copy the path of a CSV file and paste it here. Be sure to use double backslashes in the path if you're on Windows, as single backslashes are used as escape characters. And paste this variable here in the function. And also import OS. Next, we need to store the weather forecast for the next 5 hours. In Colab, we used a list comprehension to generate these times. Instead of keeping this in a list, assign each hour to a separate variable. We do this because in HTML templates, it's easier to display separate variables for each time value rather than looping through a list. Similarly, repeat this process for temperature and humidity forecasts. Now, we need to store all the data we want to display on our web page inside a dictionary. This dictionary will then be passed to our HTML template to render the data dynamically for the user. First, let's create a variable called context. This will be our dictionary where all the data will be stored. Inside this dictionary, we'll add key value pairs. The key is a string that will be used in the HTML template, and the value is the data we want to display. Since the user inputs the city name, we need to store this in our context. Let's start by adding the city. The key will be location, because that's what we'll call it in our HTML template, and the value will be the city variable that was defined earlier. And we've already fetched live weather data using this function, and this data is stored in the current _weather dictionary. Why am I calling it a dictionary? Because this function will return a dictionary. So, to display each piece of weather information, we'll access the appropriate key from this dictionary. Here's how we'll add the live weather details to our context. We retrieve the current temperature from the current weather dictionary and store it under the key current temp. Similarly, we fetch the minimum temperature. And the maximum temperature. Let's continue adding more weather details to the context. We get the feels like temperature, how the temperature feels to a human. So, add it. Next, to add the current humidity, we use After this, we want to show cloud coverage. Which I might not have fetched earlier. We need to extract this from the weather data and add it to the context. Here's how we can fetch cloud information from the API response. And add one more value here, which is visibility data. Okay, now add cloud data in context. After this, add a brief weather description like clear sky or partly cloudy. Next, add city and country. Next, to display the current date, and time on the web page, we can use Python's datetime module to fetch the current date and time. Display the current date in a readable format, like October 11th, 2024. Then, we want to display additional information like the wind speed, pressure, etc. So add those here. Since we want to display predictions for the next 5 hours, both temperature and humidity, we'll store the forecast data in separate variables. In Google Colab, we calculated these values, so now we'll adjust the code for Django. First, we extract each forecasted time from the list of future times and store them individually. Similarly, we get the predicted temperatures for each hour. And we get the predicted humidity values for each hour. Once we've gathered all this data in our context dictionary, we need to pass it to our template, the HTML file. This is done using Django's render function, like this. This renders the weather.html template, which we'll create now, and passes the context dictionary so that the template can display the weather data. If the request method is not post, like when the page is initially loaded, render the same template without context. We've now adapted our Colab code to work within a Django view. We've replaced input function with Django's form handling method, removed unnecessary print statements, properly managed file paths, and prepared the data for rendering in an HTML template. By following these steps, we can integrate live weather predictions into our web app and display the forecast to users in an intuitive way. All right, now let's create the weather.html file and set up our static assets like CSS, JavaScript, and images. This will ensure our web app looks good and functions properly. Here's how to create the weather.html file. Inside your Django app directory, Forecast, create a folder called Templates. Inside the Templates folder, create a file named weather.html. Now the question is, why use the Templates folder? Well, in Django, HTML files are placed inside the Templates folder because Django looks for templates here when rendering views. Keeping HTML files in the Templates folder maintains a clear structure and ensures Django can easily locate them. And to set up our static assets like CSS, JavaScript, and images, create a folder named Static inside the Forecast app directory. Then, inside the static folder, create 3 subfolders: CSS, JS, and IMG. Your static folder structure will look like this. But why create the static folder? Well, Django requires static files such as style sheets, JavaScript, and images to be stored in the static folder. This separates these files from your templates and back-end logic, making the project more organized and maintainable. Now create other necessary files. Inside the CSS folder, create a file named styles.css. This file will handle the styling for our weather.html page. Inside the JS folder, create a file named ChartSetup.js. In this file, we'll write logic to handle chart rendering for weather predictions. For the IMG folder, I already have some images in a separate directory, so I'm just pasting those here. You can find the images link in the description. Now that we've set up the necessary files and folders, let's start coding in the weather.html file. First, type the exclamation symbol and press Enter, and it will automatically generate the basic HTML structure. If it doesn't generate automatically, you can manually type it in. The first line is a declaration that defines the document type. The HTML tag is the root element of an HTML document, and this specifies that the language of the document is English. This helps with accessibility in search engines. The head tag contains meta information about the web page, such as style sheets and scripts. Next, after the head tag, type %load static %. This is a Django template tag that enables you to load and manage static files, such as CSS, JavaScript, or images. By using this tag, you can later reference static assets in your HTML with the static tag. For example, you'll use this to link style sheets, scripts, and icons stored in your project's static folder. After that, update the title tag to give your page a meaningful title. In this case, set it to Weather Forecast to match the content of the web page. As we need to use icons on our website, we'll use Bootstrap icons. To include them, we need a CDN link. Search for Bootstrap icons and click on the official site. Scroll down to find the CDN link. Copy the provided line and paste it into the head section of your HTML file, like this. After this, let's add a favicon, which is the small icon displayed in the browser tab with the page title. You often see favicons on most websites. To add the favicon, type this. This attribute specifies the location, URL, of the favicon file. Since we're using Django, we use the static template tag to reference static files, like images, CSS, or JavaScript. The static tag instructs Django to look for the file in the static directory of your project. Then specify the path to the favicon image within the static folder. Before using this, ensure you have added the load static tag at the beginning of your HTML file. This tag makes the static functionality available in the template. Next, to style our web page, we need to link the styles.css file to the HTML page. You can do this by adding this line. In this line, we use the static template tag again, which tells Django to locate the styles.css file in the CS folder within the static directory. We'll use this static tag for referencing all our static files throughout the project. Now, let's move on to the section. Everything we write within this body tag will be visible to the users. First, let's add the main tag, which will represent the main content of the web page. Since we have a background image that changes dynamically based on the weather description, we'll create a class for this tag. Inside the class, we will use the description variable that we passed through the Django template context. We will define this class in the styles.cs file later. Next, we'll create the sidebar section. To do this, we start with a section tag and assign it the class side container. Just like before, we'll define this class in the styles.cs file later on. Since user has to input the city name and we have to collect this user input. For this, we'll define a form element. Then type method.cc post, which ensures data is sent securely to the server. Next type CSRF_token. This inserts a security token to prevent cross-site attacks, which is required in Django forms. Then, create a div tag with the class search container. This will serve as a container for the input field and the search button, helping to organize the layout of your weather search functionality. Now, let's create a new div to hold the weather icon. Inside this div, we'll add some styling to position the icon appropriately. To display a cloud icon from Bootstrap icons, search for cloud in the icon library click on the desired icon and copy the provided line of code. Then paste it into your div. Next, we need to get input from the user. So we'll define an input element. The value attribute dynamically fills the input field with the current location passed from the backend, ensuring that users can see the location they are querying. After that, create a search button using the button element to submit the form. Similar to the cloud icon, you can add a search icon by following the same process. Search for search icon in the Bootstrap icons library. Copy the relevant code and paste it inside the button. With this, our form is now complete. Next, outside of this form, but still within the same section, we will write the code to display the current temperature, how it feels, humidity, and cloud cover. To display this content, start by creating a div element with the class daystats. This container will hold the weather statistics for the day. Inside this div, add an h2 tag with the class daystats temperature. Within this h2 tag, create a span element with the class daystats temperature value. In this span, insert the current _temp variable that we defined in the context dictionary. This will dynamically display the current temperature on the web page. Next, to display the feels like temperature, you will create another h3 tag with the class daystats feels like. This code represents non-breaking spaces. They create space between elements without causing a line break, keeping the layout neat and organized. Inside this tag, include a span element that references the feels like variable. To show humidity and cloud coverage, first create an unordered list. Within this list, add a list item for the humidity. Inside the list item, you can use a paragraph tag to display the humidity value, along with the text of humidity. Similarly, create another list item for the cloud data. Finally, to enhance the appearance of the sidebar, include a background image. You can retrieve the image path using the static template tag to link to your static files. For this, we will use a blur image that adds visual depth to the sidebar. Now, create a new section for the main weather display. This section will contain key information about the weather forecast. Here, add an H4 tag with the class secondary title. This serves as a subtitle indicating that the following content will present the weather forecast. Then type This H1 tag is the main title of the section. It displays a dynamic description of the weather pulled from the description variable defined in the context dictionary. Next, we create a div with the class weather location to group the location-related information together. Inside this div, create another div and some inline styling. This div will serve as a location icon. It uses an icon from Bootstrap Icons. Now, create a p tag here, which will contain the location text. Inside it, we use span tags to display the city, country, date, and time dynamically. Each variable corresponds to the relevant context data. Outside of this div, use p tag. It'll begin a new paragraph for the primary weather statistics. Now, write code like this. In this block, we present various weather statistics, including wind speed, pressure, visibility, and temperature. The values are dynamically populated using variables defined in the context. Finally, we start an unordered list with the class forecast to display the weather forecast for the upcoming times. Each forecast will have a paragraph displaying the time, where time 1, time 2, etc. are variables that will be dynamically populated with the respective time values. The temperature will display in a separate paragraph. The non-breaking space is to add spacing before the temperature value. The temperature itself will be pulled from the corresponding variable. Temp 1, Temp 2, etc., within a span tag, allowing for additional styling if needed. Now copy this code to repeat the structure for time 2, time 3, time 4, and time 5, which means each forecast will dynamically generate based on the values provided in the context. At last, we need to include a canvas element with the ID chart. This is where we will likely display a chart related to the weather data, such as a temperature graph. Next, we'll link the ChartSetup.js file to our HTML so we can use it to set up our chart. To include the ChartSetup.js file, we'll add a script tag right before the closing body tag in HTML file. This ensures the script runs after the HTML content has been loaded. And to get started with charts in JavaScript, we need to include a CDN link for the chart.js library. Open your web browser and search for CDN-chart.js. Click on an official website. Copy the CDN link. Paste this link above the script for your ChartSetup.js in the HTML, like this. By doing this, you ensure that Chart.js is loaded before your custom script, allowing you to utilize Chart.js features in your ChartSetup.js. Alright, our HTML file code is complete. Next, let's add some CSS to make it visually appealing. After that, we'll add some code to the JS file for the chart, and then we will be done. Now, in this file, start by importing the Poppins font from Google Fonts, as it will help maintain a clean, modern look for the weather app. This will be done like this. Next, apply some global styles. Remove default padding and margins from all elements. Set box sizing to border box for consistent layout behavior. And apply the Poppins font across the entire document for consistency. The body of the document will have a dark background to enhance the contrast of the content. Center everything both horizontally and vertically by using Display Flex, along with Align Items Center and Justify Content Center. Additionally, ensure that the body takes up the full viewport width and height. For the main container, position it absolutely and set it up as a flexible box layout with the content spaced evenly. Also add a border radius of 25 pixels to round the corners and hide any overflow content. The background will be dynamic, changing based on the weather conditions. Make sure to apply a background image specific to each weather condition, like sunny, rain, or snow. For different weather conditions, set specific background images. For example, if the weather is sunny, I will apply an image of sunny weather. Similarly, for rain, use a rain image, and so on. Next, let's define a side container to hold various UI elements like the search box and day stats. The container will be flexbox based, so it will allow easy stacking of elements vertically. I will also add padding and a border to separate it visually. This container will have a glassy effect using background. With a blur effect using backdrop filter. Next, work on the search box that users will use to search for weather data. It will be a flexible container so that the input field and button align properly. The input will have a placeholder style. And also ensure that the button looks clean by removing any default appearance and styling. For the day stats section, which will show the current weather information, arrange it as a vertical flexbox container, and align everything centrally. The temperature will be displayed in large, clear font sizes. While other details like feels like temperature and conditions will be styled smaller. For weather condition details, use a list structure and space the items evenly within the container. Then, apply styles to ensure the text appears clear and legible against the background. Finally, the main container will hold the weather forecast, which I will make a flexible box for displaying each forecast item in a row. The weather forecast items, such as temperature and wind speed, will have clear fonts and be styled to look clean and modern. Now that our styles.css file is complete, let's move on to testing it before adding any code to ChartSetup.js. Enter a city name to see how the app looks so far. Okay, looks like we've hit an error, but this is actually good because it'll help us understand how to troubleshoot and correct mistakes. The error is pointing to an issue with the visibility variable in line 212 of views.py. So I'll go ahead and check that file first. Here it is. I'll copy this and paste it here. Now save the file. After making the necessary corrections, now test the app again to confirm. As you can see, it's working perfectly now. With that sorted, I can move forward and add the code for the chart. So, let's jump into that next step. Now add the code to generate a line chart for temperature data. We'll start by wrapping our chart setup in a DOM content loaded event listener. This ensures that the code will only execute after the DOM has fully loaded. Here's what the event listener does. The first thing we're doing is grabbing the HTML canvas element where our chart will be drawn. If the element doesn't exist, we log an error message and stop the script from running further. This is a good practice for handling possible issues. Next, we get the context of the canvas using getContext. This allows us to draw on the canvas using chart.js. We're creating a linear gradient for the line color of the chart. The Create Linear Gradient method creates a vertical gradient from top to bottom, starting with a red color at the top and ending with a greenish-yellow color at the bottom. We now need to collect the temperature and time data to display on the chart. We do this by selecting all elements with the class.forecast item dot. For each of these items, we extract the time and temperature values using their respective classes. .forecast time and .forecast temperature value. We also added a placeholder for humidity, .forecast humidity value. But for now, we're focusing on temperature and time. We ensure that the values are valid before pushing them into our arrays times and temps. Before proceeding, we check that we've successfully collected both temperature and time data. If either of the arrays is empty, we log an error and stop the execution. Finally, we create a new chart we apply our previously defined gradient to the border color of the line. And adjust settings like border width, tension, and point radius to control how the line looks. It's a line chart where the times array serves as the labels for the x-axis and the temps array is the data for the y-axis. Now, after running this, we should see the chart displaying temperature data dynamically. Great. Now that we can see the chart displayed along with all the other weather information, this brings us to the end of this tutorial. We've successfully built an amazing machine learning model, retrieved live data, and integrated it all into our web page. If you want to take it a step further and deploy this website to make it live, let me know in the comments below. And don't forget to subscribe to stay updated with more tutorials like this. Thank you for watching, and I'll see you in the next one.